Hello everyone, my name is Jing Xie from Pennsylvania State University's Computer Science and Engineering Department. Today I want to demonstrate a 3D chip design with on-chip DRAM stacking of our group. 3D technology has become one of the most promising methods in today's integrated circuit design and manufacturing. With 3D, we can divide the chip into several layers and connect them together. Obviously, the yield of single chip can increase and the interconnection latency can be largely decreased. Moreover, 3D provides a new way to realize heterogeneous systems, break memory wall, and increase the possible pin number. In our design, we have 3 DRAM layers, 2 for the DRAM cell and 1 for the peripheral logic. The second logic layer will connect with this DRAM peripheral logic. For the 2 logic layers, we use face-to-face and wafer-to-wafer bonding. The face-to-face bonding will reduce the interlayer communication latency. For the logic to DRAM bonding, we choose the back-to-back and die-to-wafer bonding, as they have different chip size. For connecting different layers, we use through-silicon via from Texon. This super contact will connect metal 1 of one layer to the backside metal of another layer. In order to guarantee the yield, we use 10 TSV cluster for DRAM signal connection and 26 TSV cluster for the I/O connection. Between the logic layers, as we use face-to-face bonding, we can use normal vias, which provides higher speed. Our design flow follows divide and conquer approach. We first divide our design into 2 Verilog files and use the design compiler to synthesize them separately. With these 2 netlists, we obtain 2 DAC files by EDA tools. At this point, we streaming both files and finish 3D design in Virtuoso. The verification part is run after all the layers stacking together. During tape-out, we give the foundry separate GDS files for manufacturing, and Texon helps stacking all layers. For reliability concern, TSV will be inserted all over the chip to meet minimum 250 microdistant density requirement. The layout view of the TSV cluster is shown in figure B and C. Our chip has 5 layers, but all the I/O pads are on one layer, the bottom DRAM peripheral layer. The normal packaging method like wire bonding can be used for 3D chips too. The functional test will be performed after packaging. Here is the layout of our 2 logic layers. We have the Unicode 2 processor and H.264 encoder on logic 1 and all the other logic and I/O TSV cluster on the other layer. According to the chip and simulation results, we can see the DRAM signal number is above 1000. Without 3D memory stacking, we cannot afford so many pins. Our group also did excellent stacking and received 4T per second bandwidth for data backup. 3D technology has so good performance in breaking memory wall and relieve the pin number constraint. Our project is supported by the following funding company and universities. Thank you for watching this video. If you have questions on our design or our research, please contact our group by the following email.